is up at the top. In the planning stages, that it says, in the planning stage, sample proportion is estimated to be 40 out of 50. Look, it may say, hey, we had 40 successes out of a sample size of 50. You gotta remember to take 40 divided by 50 and find that proportion. That's where a lot of you will get stuck and you'll get stuck on that first step. Let me repeat that. Because this is what happens when there's a question where it's not giving you the proportion, that you have to calculate the proportion. It will say something like, there are 40 people left-handed out of a sample of 100. You're gonna take 40 divided by 100 to get that proportion. So in this case, it's giving you 40 out of 50, and it literally calculated for you 80%, 0.80. Use this information to compute the minimum sample size, which is going to be n, required when you want to estimate a 99% confidence. And your desired margin of error is 12%, plus or minus 12%. You ready? And then it says, what happens if you decide to change the confidence to 90%? Let's just start with 99% confidence. 12% error, 80% is our proportion. Are you ready? What's my first step? Find the z. So which formula are you using, top or bottom? Bottom, because it's proportion. Very good. Okay, we're starting with 95% confidence. Is that right? 99. 99, is that right? 99. So the number here is going to be, again, 995, which means it's going to be, just like before, 2.576, which means this turns into 2.576 squared. The given proportion is, how much is the given proportion? 80%. 0.80 times 1 minus 0.80, and the amount of error, 0.12 squared. There's the setup. Oh my God, this is almost too easy. I can't believe you guys aren't sleeping. They're not sleeping. I know we can only see the back of the heads of the front row. I looked at the left right here. Let me keep looking here. Show me 2 calculations, come up with that answer here, and then make sure to round up. Hey, you know, I think I have the answer to this one, because I'm about to post it, so I know it's in here somewhere. Right there. Okay, there it is. So here it is right here. 2.5, okay. Let's do it a different way. Here it is. 1 minus 80% times 80% times 2.576 squared divided by 0.12 squared. Here's a little math, I guess. 21.4 blah, 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 times 16. 73.73. We have to round up, so the optimal amount would be 74. The only thing that would change, the question then says, hey, switch the percentage from 99% to 90%, is that right? 90%? The only thing that changes if we switch to 90% is this right here, the z. Everything else stays the same. Switching to z and 90%. So if you notice, the only thing that we switch here is going from 2.576 to 1.645. Now, look at how different though. Going from 99% confidence, we gotta have a large sample size to have that much confidence in it. But if we're only going 90% confidence, well, we can have a much smaller, or less than half the sample size if all we need is 90% confidence. All depends how important the information is that you're relaying to somebody else. Hey, I have 90% confidence that according to our sample, the proportion in the population is somewhere between here and here. 90% confidence, or I have 99% confidence. Then it's going to be either a much larger sample size or a wider confidence interval.